Welcome to Z Science, the place where curiosity softens into calm. As the world around you slows, your mind can drift toward the quiet patterns that shape our universe. Whether you are lying under warm blankets or letting your thoughts wander in the dark, I am glad you chose to end your day here. If you enjoy learning while you relax, you can help this small channel grow by liking and subscribing. It makes a real difference. To everyone who has already joined, thank you for being part of this slow exploration of the cosmos. Let your breath settle. Let your body sink deeper into rest. Tonight we travel to places where stars gather, stretch, and sometimes tear away from one another. Settle in. What really happens when the universe decides to reshape itself? Collisions in space may sound dramatic, yet they unfold on timescales so vast and serene that they are less like car crashes and more like a slow cosmic waltz. Galaxies, immense collections of stars, gas, and dust, are not fixed in place. They move, pulled together by the invisible threads of gravity, drawn into graceful encounters that reshape them over billions of years. In this exploration, you'll discover how these celestial gatherings unfold, what becomes of the stars and planets caught in their embrace, and what roles black holes and dark matter play in this grand choreography. We will also look ahead to the distant future when our own Milky Way will meet its neighbor Andromeda, in a union written into the stars long before life appeared on Earth. These stories are not rushed. Like the galaxies themselves, we will drift slowly, pausing to notice the quiet beauty of each step along the way. Because within the great collisions of the universe lies a reminder that change, no matter how immense, can be both gentle and profoundly creative. If you could step back far enough, beyond the reaches of our solar system and the faintest glow of our neighboring stars, you would begin to see that the universe is not scattered randomly, but arranged in vast glowing cities of stars. These are galaxies, immense structures bound together by gravity, each containing hundreds of billions of suns, swirling gas, drifting dust, and an invisible substance called dark matter that outweighs everything we can see. Galaxies are not small embellishments on the canvas of the cosmos. They are the fundamental building blocks of the universe, the great archipelagos in an endless cosmic ocean. A galaxy is not a single entity so much as a community. Imagine a city viewed at night from far above. Each shining light is like a star, and together they form patterns of streets, districts, and neighborhoods. A galaxy is very much the same, but on a scale the human mind struggles to hold. The Milky Way, for example, is our home galaxy, a barred spiral system with somewhere between 200 and 400 billion stars. Many of those stars host their own planets, and around some of those planets, perhaps, life may stir. Yet even with all this complexity, the galaxy remains a single unit, circling around its center like a grand wheel. What keeps these stellar metropolises together? Gravity, the quiet architect of the universe, the force that ensures stars do not simply drift apart into the void. Galaxies hold together because their combined mass bends the fabric of space, pulling stars, gas, and dust into a coherent structure. However, the visible material we can see, the stars, the shining nebulae, and the glowing clouds, is only part of the story. There's also dark matter, an unseen framework that makes up most of a galaxy's mass. We cannot see it directly, but without it, galaxies would not have the gravitational glue to remain intact. They would simply spin apart like a poorly tied bundle of fireworks. Galaxies come in different shapes and personalities, each sculpted by its history and environment. The most famous are spiral galaxies, graceful disks with long arms that curl outward like cosmic pinwheels. These arms are not solid structures, but waves of density that encourage gas to collapse and form new stars, giving spirals their blue-white sparkle. Our own Milky Way belongs to this class, complete with a central bar of stars stretching across its core. When viewed from afar, spirals are breathtaking grand whirls of light, as if the universe itself enjoyed doodling on the largest scale imaginable. Then there are elliptical galaxies. These are less ornate, often resembling smooth, glowing ellipsoids, without the distinct arms of a spiral. Their stars are older, their light more golden, and they typically contain less gas and dust for new star formation. Many of the largest galaxies in the universe are ellipticals, bloated, giants that may have grown through the collision and merger of smaller systems. They are the stately elders of the galactic family, less flashy perhaps, but carrying the weight of history. The irregular galaxies, by contrast, defy neat categories. They appear chaotic, often the result of gravitational encounters or turbulent pasts that disrupted any clear shape. Some are small, others surprisingly large, but they share one trait: unpredictability. Where spirals and ellipticals can be neatly catalogued, irregulars are the universe's rebels. A reminder that not everything in nature follows a tidy diagram. Astronomers have also noticed that galaxies can be grouped by size. There are giants containing trillions of stars, and there are dwarf galaxies with only a few billion. Dwarfs are actually the most common type, like scattered cottages compared to the grand skyscrapers of spirals and ellipticals. Our own Milky Way is attended by several dwarf companions, such as the Large and Small Magellanic Clouds, which are visible from the southern hemisphere as misty patches of light. In time, these smaller galaxies will likely be absorbed into the Milky Way itself, illustrating that galaxies are not static, but ever-changing participants in the cosmic drama. It's easy to picture galaxies as still, painted across the heavens like decorations, but in truth they are dynamic. Stars orbit their galactic centers. Clouds of gas drift and condense, and spiral arms shift like ripples across a pond. A galaxy is not a frozen snapshot, but a living system evolving over billions of years. From the birth of new stars and bright nurseries to the quiet fade of ancient suns, galaxies contain the entire cycle of stellar life, vast libraries of cosmic history, with every star a page and every cluster a chapter. Despite this richness, galaxies are surprisingly delicate. The structures we see, spiral arms, bars, discs, exist only because of a careful balance between gravity, rotation, and mass. Disturb that balance, and the shape can be transformed. Collisions, interactions, and even the slow pull of neighbors can twist and reshape galaxies, leading to strange bridges of stars or elongated tails. In many ways, galaxies are both resilient and fragile, surviving for billions of years, yet always susceptible to change. When astronomers first began to study the faint smudges in the night sky, there was great debate about what they were. Were these clouds within our own Milky Way, or were they island universes beyond? It was not until the early 20th century that Edwin Hubble provided clear evidence that these smudges were galaxies in their own right, far outside our own, each with its own stars and structures. Today, thanks to powerful telescopes, we know there are more galaxies in the observable universe than grains of sand on Earth's beaches. That number stretches into the trillions, each one a city of stars, each one a story in the making. In this immensity, our Milky Way may seem ordinary, but in reality, it is anything but. It is a spiral galaxy about 100,000 light-years across, spinning gracefully through space. At its center lies a supermassive black hole, a hidden giant around which everything turns. From our vantage point, we see the galaxy as a pale band of light arcing across the night sky. A reminder that we live not just in a solar system, but as citizens of a much larger, grander community. Galaxies are, in a sense, the universe's neighborhood associations, but with fewer arguments about lawn care and more about who gets to consume the next passing dwarf companion. They are the social units of the cosmos, rarely isolated, often interacting, sometimes combining, and always shaped by their environment. Whether spiral, elliptical, or irregular, whether giant or dwarf, every galaxy carries its own identity, its own rhythm, and its own place in the vastness of space. To understand galaxies is to understand the stage on which the universe plays out its grand story. They are both the backdrop and the main characters, silent and majestic, yet never static. And though the human eye sees only a handful on a clear night, telescopes reveal the truth. Galaxies are everywhere, stretching to the horizon of the universe, each one turning slowly in the darkness. Each one a beacon of light against the infinite night. The universe may appear at first glance to be a place of stillness. Stars seem fixed in their constellations. The Milky Way arches steadily across the night sky, and galaxies look like silent smudges suspended in the void. Yet behind this calm facade lies constant motion. Galaxies drift, swirl, and sometimes collide, all under the influence of forces that are both familiar and mysterious. To understand why galaxies behave the way they do, it helps to meet the great shapers of the cosmos: gravity, the ever-present sculptor, and dark matter, the unseen hand guiding the dance. Gravity is perhaps the most famous of nature's forces, though it tends to get taken for granted. After all, it is the reason your feet stay on the ground and why coffee cups have such a tragic tendency to smash when they slip from the table. Isaac Newton was the first to describe it in precise mathematical terms, showing that the same force that pulls an apple toward Earth also keeps the moon in orbit and the planets circling the sun later. Albert Einstein expanded the picture with his theory of general relativity, revealing that gravity is not so much a force pulling objects together as it is the bending of space and time itself. Massive objects curve the fabric of reality, and everything else follows those curves. On the scale of galaxies, gravity is the master artist. It gathers matter from the early universe into clumps, squeezes gas into stars, and shapes entire galaxies into spirals, ellipses, or irregular clouds. Without gravity, there would be no stars, no planets, and no people wondering about stars and planets. It is the quiet director of the cosmic stage, invisible but absolutely relentless. If the universe were a grand sculpture garden, gravity would be the sculptor's hand, patiently chiseling over billions of years. Yet gravity alone does not explain everything. When astronomers first began to study galaxies in detail, they noticed something puzzling. By looking at the way stars orbit within a galaxy, one can calculate how much mass must be present to keep them bound together. The problem was, the visible matter, the stars and glowing gas, was not enough. Galaxies were spinning too fast to be held together by what could be seen. According to the math, they should have torn themselves apart long ago. Clearly something was missing. That missing ingredient is what scientists now call dark matter. Despite the name, Dark matter is not some sinister substance lurking in the shadows. It simply means matter that does not emit, absorb, or reflect light. In other words, it is invisible to our eyes and to most of our instruments, detectable only through its gravitational influence. Current estimates suggest that dark matter makes up roughly 85% of the matter in the universe, vastly outweighing all the stars, planets, gas, clouds, and galaxies we can see. Think of a galaxy as a glowing lantern surrounded by an enormous, invisible balloon. The lantern is the stars and dust, but the balloon is dark matter holding everything in place. Without this unseen framework, galaxies would not exist as we know them. They would be unstable collections of stars, unable to maintain their beautiful shapes. Dark matter is the silent scaffolding of the universe, keeping the luminous structures we admire from flying apart. Although dark matter remains mysterious, we do know what it is not. It is not made of the familiar atoms that compose you, me, and the chair you're sitting on. It is not ordinary matter hidden in dark clouds or faint stars. Decades of observations have ruled out such possibilities. Instead, it appears to be something entirely different, some new kind of particle that does not interact with light. Scientists around the world are building sensitive detectors buried deep underground, hoping to catch the faintest whisper of dark matter passing through. So far, it remains elusive, but its fingerprints are everywhere in the heavens. Together, gravity and dark matter shape the grand architecture of the universe. They do not act in isolation. Rather, they cooperate to weave the cosmic web. Galaxies gather at the intersections of vast filaments of dark matter, forming clusters and superclusters. In between lie immense voids, regions nearly empty of galaxies. This large-scale structure of the universe looks remarkably like a three-dimensional spiderweb stretched across billions of light years. If you could step outside the universe and glance back, you would see threads of galaxies tracing the unseen scaffolding laid down by dark matter and pulled tight by gravity. Now, why do galaxies move at all? After all, if gravity is binding them so carefully, shouldn't they remain in neat stationary arrangements? The answer is that galaxies are born with motion. In the early universe, tiny fluctuations in density gave some regions a slight advantage in pulling in matter. As these regions grew, their gravity attracted more material, which fell inward, not in straight lines, but along curved paths. This imparted spin and drift to galaxies as they formed. Even today, galaxies continue to move under the gravitational influence of their neighbors. The Milky Way, for example, is not floating idly in space. It is hurtling toward the Andromeda galaxy at several 100,000 miles per hour. Fortunately, space is so vast that even at such speeds, the collision will not happen for another 4 billion years. On the human scale, that feels like forever, but in cosmic terms, it is just around the corner. The point is that galaxies are not isolated marbles. They are participants in a vast gravitational dance, each step influenced by every other partner. One of the most beautiful consequences of this motion is that galaxies often interact. Some merely brush past each other, distorting their shapes with tidal forces, while others embrace fully, merging into new forms. Gravity choreographs these encounters, pulling on the outskirts of galaxies long before their centers come close. Stars are shifted into long tails, gas clouds are squeezed into new star-forming regions, and central black holes may eventually spiral together. What seems like chaos is in fact the orderly unfolding of physical laws across incomprehensible distances. It is worth noting how patient gravity is. Human beings are used to thinking of collisions as violent, destructive events that happen in fractions of a second. On galactic scales, a collision is more like two clouds drifting together, slow process lasting hundreds of millions of years. The forces at play are immense, but the pace is serene. Gravity works with a time scale so generous that even stars live and die, while galaxies gradually merge. Dark matter, too, plays a critical role in these cosmic interactions. When two galaxies collide, their visible matter may distort dramatically, but their dark matter halos interpenetrate like two invisible balloons brushing past one another. These halos are so much larger than the galaxies themselves that they help guide the outcome of the merger, shaping the final structure. Observing such events gives astronomers one of the best tools for mapping the otherwise invisible distribution of dark matter. In all of this, a profound truth emerges. The universe is not static. It is not a silent museum of frozen exhibits, but a living, shifting network of galaxies sculpted by forces both visible and hidden. Gravity bends the paths, dark matter holds the frames, and together they create the conditions for beauty on the grandest scales. To look at a galaxy, then, is to see the balance of power between what we know and what remains mysterious. It is to witness the patient artistry of the cosmos, a design carved not in stone, but in stars. Understanding these forces does not just explain why galaxies look the way they do. It also reveals why the universe is structured at all. Without gravity, matter would never have gathered into stars. Without dark matter, galaxies would never have held together long enough for those stars to form planets and for life to emerge. Every breath, every thought, every dream owes its existence to these silent cosmic shapers. The universe is vast, but its story is written by surprisingly few characters, each with a role as old as time itself. Galaxies may look like fixed ornaments in the night sky, but they are anything but static. They are ancient travelers, evolving and reshaping themselves across spans of time so vast that even the life cycle of stars seems fleeting in comparison. To understand galaxies is to step outside the human sense of time altogether and into a realm where billions of years unfold like chapters in a long, unhurried story. Every galaxy begins as a gathering of matter in the early universe. After the Big Bang, about 13.8 billion years ago, the cosmos was filled mostly with hydrogen and helium gas, spread almost evenly. Yet even in this near-uniform sea, there were tiny ripples, slight variations in density so small they might seem meaningless at first. Over immense stretches of time, gravity amplified these ripples, pulling more matter into the slightly denser regions. What began as a faint imbalance eventually grew into the first clumps of stars in the earliest galaxies. These primitive galaxies were small, irregular, and often chaotic in shape. They contained only young, bright stars, since older generations had not yet existed long enough to age and fade. Gas was abundant, fueling vigorous bursts of star formation. Compared to the majestic spirals and massive ellipticals of today, these early galaxies were like seedlings just sprouting from the soil. They lacked symmetry, but they carried the potential for growth and change. As billions of years passed, galaxies evolved through both internal processes and external encounters. Internally, stars were born, lived out their lives, and died, enriching the surrounding gas with heavier elements like carbon, oxygen, and iron. These elements made it possible for planets to form around stars and eventually for life. to emerge in at least one corner of the cosmos. Each generation of stars left its fingerprint on the galaxy's character, gradually shifting its light from a youthful blue to a more mature golden glow as younger stars became less common. Externally, galaxies were constantly shaped by interactions with their neighbors. In the crowded early universe, collisions were far more common than they are today. These encounters were not brief accidents, but long, drawn-out events lasting hundreds of millions of years. When galaxies collided, their stars usually pass by one another without direct impact. After all, stars are tiny compared to the distances that separate them. Yet the overall structures of the galaxies changed dramatically. Gas clouds crashed together, triggering waves of starbirth. Spiral arms might be stretched into tidal tails, and two colliding galaxies might eventually merge into a single, larger system. It is tempting to think of collisions as destructive, but in reality, they are creative as well. Without them, galaxies would not have grown to the immense sizes we see today. The giant elliptical galaxies that dominate the centers of clusters are thought to be the products of many mergers over billions of years, a record of cosmic cannibalism written in starlight. Even the elegant, spiral form of the Milky Way is not eternal. Its history includes smaller collisions that have left streams of stars arcing across the galactic halo. And its future almost certainly includes a grand union with Andromeda. This long life cycle of galaxies reveals how dynamic they truly are. A spiral galaxy may eventually lose its gas and slow its star formation, becoming redder and more quiescent. Over further billions of years, repeated mergers can smooth away the delicate spiral arms, leaving behind a more rounded elliptical form. By then, most of the galaxy's stars are old, glowing faintly as they exhaust the last of their nuclear fuel. The galaxy itself, though still vast and luminous, begins to quiet a once bustling city, gradually settling into a calm twilight. Timescales like these are almost beyond human imagination. To say that a collision between galaxies takes hundreds of millions of years is one thing. To truly grasp it is another. For perspective, the entire span of human civilization, from the earliest agricultural villages to the skyscrapers of today, covers only a few thousand years. Even the rise and fall of the dinosaurs occupied just a few 100 million years, a single chapter in a galaxy's life. Galaxies do not hurry. Their transformations unfold at a pace so measured that entire species and civilizations come and go, without the galaxy noticeably changing at all. Gas dynamics play an especially important role in these cosmic encounters. Unlike stars, gas clouds are large enough to collide directly. When they do, shock waves ripple through them, causing the gas to lose energy and sink toward the galactic center. This process can feed supermassive black holes lurking at the hearts of galaxies, causing them to flare into active galactic nuclei. These brilliant beacons, sometimes brighter than the entire galaxy itself, are powered by matter spiraling into the black hole at nearly the speed of light. In this way, collisions can awaken dormant black holes, turning quiet galaxies into quasars visible across the universe. From the human perspective, the pace of all this is unimaginable. A galactic collision does not happen overnight. The initial approach may take hundreds of millions of years, followed by a drawn-out dance of close passes, separations, and reapproaches. Only after perhaps 1 billion years do the galaxies finally coalesce into a single structure. To put that in perspective, 1 billion years is roughly the time it took for simple life on Earth to evolve into complex, multicellular organisms. While galaxies slowly weave themselves together, entire worlds can rise, flourish, and fade without ever witnessing the full event. For astronomers, the study of galactic collisions is both a window into the past and a forecast for the future. By observing galaxies in various stages of merging, they can reconstruct the life cycle of these grand encounters. The antennae galaxies, for example, are two spirals currently in the throes of collision, their long tidal tails arcing outward like insect feelers. The Whirlpool Galaxy shows evidence of a smaller companion disturbing its structure, tugging on its spiral arms. Each of these cosmic examples is a snapshot of an ongoing story, a frozen frame in a film that plays out over eons. In understanding these collisions, we also come to appreciate the role of patience in the universe. To human eyes, they might seem catastrophic, but on cosmic timescales, they are neither sudden nor ruinous. Instead, they are natural steps in the evolution of galaxies essential for growth, renewal, and change. If galaxies could speak, perhaps they would not describe these encounters as disasters, but as transformations, opportunities to become something new in the end. The science of galactic collisions reminds us that appearances can be deceiving. What seems like destruction is often creation in disguise. The stars carry on undisturbed, the gas ignites with fresh energy, and new galaxies emerge from the union. Rather than imagining fiery wrecks in space, it is better to picture a slow dancer, blending of structures guided by gravity and lit by the birth of countless new suns. It is a vision not of violence, but of cosmic renewal, written across billions of years in the light of the stars. When two galaxies meet, the result is not simply a rearrangement of stars and gas, but a display of cosmic artistry. These encounters create structures so striking that even seasoned astronomers are left in awe. Long tails of starlight unfurl into the darkness. Bridges of matter stretch between galaxies like glowing handshakes, and delicate streams arc across space in patterns that resemble brushstrokes on a canvas far larger than any human imagination. This is why galactic collisions are often described as ballets. They are graceful, deliberate, and hauntingly beautiful. One of the most captivating features of these encounters are tidal tails, elongated streams of stars and gas that extend outward from colliding galaxies, sometimes stretching for hundreds of thousands of light years. They form when the immense gravitational pull of one galaxy distorts the structure of another, tugging on its outskirts and flinging material outward in elegant arcs. To an observer, tidal tails look like ribbons of light drifting into the void, their curves echoing the flow of gravity itself. Some tails eventually curl back, falling into the merged galaxy, while others remain as faint reminders of past interactions. Lingering for billions of years, bridges are another common feature of galactic interactions. These glowing connections form when material is drawn from one galaxy to another, creating a luminous thread between them. To the eye, these bridges resemble trails of starlight linking to islands in the dark ocean of space. They are the visible evidence of gravitational attraction at work, a cosmic tug-of-war, rendered in stars and gas. Over time, such bridges may collapse back into their galaxies, but for the duration of their existence, they give the impression of galaxies reaching out, almost touching. Streams of stars can also result from collisions, formed when galaxies tear smaller companions apart. These streams, often faint but remarkably long, wrap around galaxies like halos or form graceful loops in the night sky. In our own Milky Way, such streams have been detected as remnants of dwarf galaxies consumed long ago. They act as the lingering choreography, of past dances, subtle yet elegant signatures, of encounters that shape the galaxy we live in. Today, the sheer beauty of these structures is amplified when seen through telescopes that capture both visible and invisible light. Observations in ultraviolet reveal bursts of new stars forming within tidal tails, while infrared views show glowing dust heated by stellar nurseries. Radio telescopes pick up hydrogen gas stretched across vast distances, mapping the invisible currents that feed star formation. Taken together, these perspectives reveal collisions not as chaotic events, but as ordered composition and each wavelength of light adding another note to the cosmic symphony, while direct observation shows us galaxies mid-performance. Computer simulations allow us to replay their entire choreography. With the help of modern computing power, astronomers can model galaxies as collections of millions of particles, each representing stars, gas, or dark matter. When two simulated galaxies are set on a collision course, the resulting images are astonishingly close to reality. Spirals twist, tails unfurl, and bridges appear just as they do in actual observations. These simulations are not only scientifically valuable but artistically mesmerizing, offering a chance to watch billions of years unfold in just a few seconds.